Okay, so in this tutorial one, we are going to uh, we are going to build uh, we are going to build or develop a simulation, a simple simulation in the steady state for the actuated sludge system. Okay, so this tutorial cover the following topic: gaining familiar with the objective of this tutorial is to gain the familiarity with the GPSX interface and the tool available, building a simple layout, and running a simple simulation. So here, this is the step. You can follow this step actually. But let me try first, and then the when you have the simulation, when you have the software, you can try by yourself. Okay. So uh, in here, after we open this software, so now we go to comprehensive. We go to library. Okay, we go to library, comprehensive carbon, nitrogen, phosphorus, pH. Okay, because in the library there are different engine actually. Okay, different target that we would like to calculate, or we would like to model. For our case, we would like to calculate the this nutrient. Okay, carbon, nitrogen, and phosphorus, organic carbon, and also nutrient by using this library. Okay. So if you want to have uh, more information, or more we would like to know the equation, something, you can go to technical reference. Okay, technical reference here. Okay, so in here we select it. So this one already select, and after that locate the process. Locate the process table on the left hand side, and and then we select the we select the component that we would like to have. Okay, so for example, for us is we would like to have the wastewater influent. Okay, so we drag it. Okay, so this is the influent. So build can represent the unit process. Control point is in the icon are separated into group and like objects such as primary treatment, suspended growth process, and biosolid treatment. So in the process contain the unit, this process table contain the unit process treatment plant. Each icon is identified by process name. The process name is also displayed in the tooltip if you hold the cursor. Okay, so we will start by building this is simple by using the influent, aeration tank, secondary is the clarifier, and wastewater outfall. Okay, so we have influent. Okay, we have the influent, we have the primary. No, we have the aeration tank. So aeration tank is incomplete mixed tank. No, it's not complete with tank. We have a okay, plug flow tank. Okay, plug flow tank. All right, so here plug flow tank, and select the circular secondary clarifier. Okay, so touch growth, and this is touch growth, suspended growth, primary treatment, secondary clarifier. Okay, here, so this is circular, and then after that we need one more waste water outfall. So this is effluent, so this is waste outfall. Okay, all right, we can zoom it, we can zoom out to see more clearly. Okay, so we can arrange it. Okay, we can view and then see the grid. Okay, something like this, and this is our this is aeration tank, this is secondary clarifier, and this is the outfall, wastewater outfall. Okay, so we got all of this. Select outfall icon, close the process. Okay, we can close the process here. Okay, so this is open the process back, this is close the process, table process. This, we can save it in case we have problem with the alright, so I save it, I put it Rimas tutorial. Okay, so this is our tutorial 1. So this is tutorial 1. Okay, so the border, this should be look like this. Okay, so let us arrange like that. Alright, and then zoom, bring the locator. So I think this one is, if we have a mouse we can just drag like this, zoom in, zoom out like this. Okay. Okay, so next we are going to as we specify the connectivity. Okay, so now next is we have to specify the connectivity between the object. Okay, this is critical in the specification of the flow sheet, as all material balance, and therefore the equation which result can based on the connectivity in the layout. When you specify this connectant, remember that the flow line are directional. It means the material flow from one initial point to terminal points of the flow connection. Okay, so we can specify the influent here. You can see here when you select on this arrow here, this is, you will see this new arrow here. So this new arrow connect to this one when it become green. Okay, and then after that this one we will connect this to this clarifier, and after that from clarifier here we connect to the outfall and clarifier. So some portion of the clarifier is coming from here to this aeration tank. Okay, so so you have to be careful, and the connection here is very important. Okay, we can rename the object. Okay, we can rename the object by using select on the object like this, right click on it, and we put the label. So this one is influent, and then this is the parameter signature. This is in this software actually is written in like Python and also from Fortran. Okay, it's this is I think Java. Okay, Java, Python, and Fortran combined together. So this is, and then as you know, mathematics is based on the variable, right? So this is the variable. So that's why here you have to note denote the variable carefully, because this variable will represent the represent the I mean this name will represent the variable. So in here we note the influence by W, this one, see there, W in. So this is represent wastewater inflow. Okay, wastewater inflow. So we accept it. And for the aeration tank, so we select it, right click on it, label. So they become aeration tank, and you see this one is directly from the previous object. So this is wastewater inflow. Then we have this one. This is F MLSS. So this is the this is overflow. So this is like mass liquid suspended solid or something like that. Okay, and then pump is number 4. Just leave it alone because we don't use pump. We don't use pump here. And then after that, this one is a RAS 1. So this RAS 1 will represent the ratio of the aqueous and solid. Okay, you know this is one some portion of the sludge and water come from the secondary clarifier. So we accept it, and then after that this is the clarifier. Right click, label. So this one is a final clarifier. So you know it must liquid suspended solid will be here, and then overflow. This is, we call it free 1. Free 1 is mean this is effluent. Okay, this is effluent 1, and then this one will be was 1. Then this one will be RAS 1. Okay, so actually this is pump here. Was 1 means this is the wastewater. Okay, but this one in our case we don't use it, so but still keep it. Okay, we accept it, and the outflow. So this is the outflow. So this one become effluents. Okay, so this one you don't need to change, because this is the amount of flow rate come from the secondary clarifier. Okay, all right. So okay, so you can see here variable name in GIS model use the connection level to identify the stream. So like QWWEN is the effluent flow rate, and QFE1 is effluent rate in this case. All right, so the plant layer is now ready. Okay, so we select the object model. So in the previous section, we select the objects, basic object to be modeled in our plant. So these objects are the major unit process and control point only. For mathematical model were assigned. No mathematical model were assigned to the various objects in the layout. Okay, so at this point, this not yet have any equation. Okay, so each object in the layout have a name of attribute or property. So meaning that in this layout we have only name and then property, as I said to you. So this is name and then this is the property, this okay. So this secondary, I mean the Eurasian tank also the same. Okay, and then one of the most important attribute for the GPSX object is that if the set of equation or model that define the dynamics behavior of that objects. Remember to distinguish between an object type and model. For that object, some objects have more than one possible model. So each object is given a default model when it when it is dropped on the drawing board, but the model choice should be verified and changed if required before proceeding. So meaning that, for example, let's say here Eurasian tank, you can change, okay. This is default, okay. The default here is let's say we see the physical, so you can see here. So this is the number of reactor in the series is four reactor, okay. Like a four cluster inside the tank, 1 2 3, okay, 4. And then the depth of the tank is around 4 meter, okay. And the maximum of volume of this the maximum volume of this tank is 1000 meter, okay. 1000 cubic meter, okay. So you can change, so meaning that before you do modeling, so if you would like to change any dimension here, for example, let's say you already have the dimension and you would like to put it here, so you can try it in here, okay. So secondary clarifiers are the same. So this is meaning that the field bottom is 1 meter, surface is around 100, and the water depth is 3 meter, okay. And then we have a flat bottom, and you can change this one, no problem. Okay, so verify the influent model. So right click on the influent icon and process the process data menu appear as shown in this tool. So we have here verify it, so meaning that now we assign the equation for the equation for each object to be model. So model here, unfortunately we have the default is already, okay. And then after that verify for the Eurasian tank, okay. So Eurasian tank is Metis 2, okay, Metis 2 already. And then we have to modify the secondary clarifier, which is simple 1D, okay. So this is a simple 1D, and out4 is a default, okay. Save the layout, you already save it several times. So you may have noticed that the process unit object process memory contain number of items specified, input parameter, initial condition, and output variable. Drop down menu which can which are available when right click on the process. You can see, for example, let's say influent, you can see okay, you can see that we have composition, flow, this one, input parameter, initial condition, and output variable. In this tutorial we reduce the default property for the object. You have to select in 4 exception. So meaning that all the parameter we maintain, and except 4, okay. So if we accept only all these parameter, for example, influent, COD, TKN, and excessive slash fatigue rate. Okay, so we go to the influence, so we change this one, we change this parameter, we go to influence composition and influence sludge here. So we change the COD, okay, from 330 to 430 to 380. So let us change this. Okay, once again. Okay, so this one, COD, we change it 380. You can notice that when we change it, the color will be changed, okay? And then the TKN is 40 to 35. 40 to 35. This one is, you did do the laboratory test for the raw sewage, right? So this one, you can see all of this parameter is here, so you can put all your parameter here, no problem. But for this demonstration, we don't change it. We change only several parameter, COD, TKN, and the other. Okay. This one. And note that okay, we change it. It is true. Okay, and then after that, in the secondary clarifier. Okay, after that, don't forget to accept it. Secondary clarifier. In the secondary clarifier, we input and then we put the operational. Okay, and then change the pump flow in 3 from 40 cubic meter per day to 60 cubic meter per day. Okay, so this one, input parameter operation, we change the pump flow from 40, we change the pump flow from 40 to 60. Okay, 40 to 60. Okay, I was wrong. In here, in this one, it is the pump. Okay, it is the pump flow. Okay, once you change this flow, press accept. Okay, once complete the layout, you will usually see the edit of the layout white property. Okay, so if you want to see the, okay, follow this one first. So once you've completed the layout, you will usually want to edit some of the plant white property. You can access this property pressing the side property, bottom, the bottom of its upper left corner of the drawing board, the window. Okay, okay, so where is the white property? We can choose here layout. Layout and plant white property. Layout. And white property. layout, site property, and plan void property. Okay, so this one. Plan void property, for example, the temperature of the liquid temperature is like 20, blowing inlet or air temperature 20. Okay, and then the barometric pressure at the value is 1, etc. Okay, to, for example, specify liquid temperature 22. Okay, we put to this one 22. And then press accept. Okay, and then to see all the variable, chain, so this one you can select it, any object. Okay, unit, and then chain. Okay, influence, for example, influence, we change it. Okay, COD and TK, TKN, and then aeration tank, no change. Second clarifier, we change the pump, and effluent we call door, and the system, we change the temperature, liquid temperature. Okay, alright, so now building a model. Okay, we can build the model now. So now we switch from the modeling here token, and then we switch to the simulation token, so it will create a model for us. Alright, so build the model now. Model has been added. Actually, this one is the process is based on the complexity of your model, and as well as your computer speed. Okay, so one, the method, the model have is compile, so it will present simulation environment as shown in this one. Okay, so this is the simulation environment. Notice that the standard unit process output for each unit layout is automatically generated in the output section. Okay, there are the quick display somewhere in this table, which will display out results after simulation are carried out. Okay, there are subdivision in the quick display, so I think this is all is marked here. Okay. Okay, so now we start the running simulation. So your model is now ready to run the simulation. The control that will need to run is our simulation toolbar found in the bottom of the screen. So this is the toolbar for the simulation. Okay, like this. See this one is running. Okay, it's quick. Effluent here, final secondary clarifier, aeration tank. This is in the influent. So this is the result in the influent. This is the result in the aeration tank, and then this is the result in the clarifier. This is the result in the effluent. Okay. Okay, so switch between the various quick display this window. Okay, so you can see this one. Okay, for example, let's say aeration tank. Okay, you can see that there's a mass flow here. So this is COD is come in, and then now this is RAS1. Yes, one here. This is RAS1. This is from the secondary clarifier. So COD from secondary clarifier is like this, and then this is the amount to get out. Okay, etc. So let's say the effluent. So effluent, you can see that the TDS is like this. COD is like 60. Let's see the COD from the influent. So COD from the influent is 306 380. So now from the effluent we got okay, okay, see, all right, see that. So influence COD, we have like 380. Effluent after the simulation, we can get the 31.40. Let's see BOD. Okay, so BOD is 196. So effluent it will be 3, right? And then if we see the final clarifier, I mean this one BOD will be much actually from the aeration tank. So this one, so 621, and then flow out to the outfall is a 3.9, and then flow out for recycle is at 1203. Sorry, yeah, 1203, etc. Okay, so this is the way we can do the simulation to verify the any objects, the objects of our unit process. Okay, not only this simple, okay, you can add more unit if you familiar with all of this. Okay, we save it, and then we complete the tutorial one.